Hey everyone, this is section 9.4 on inscribed angles. I would like you to look at this red angle, angle B, and this blue angle, angle A. I want you to notice that both of the angles cut off the exact same arc here. Here's an arc. Notice how angle B cuts off this arc and angle A cuts off the same arc. So my question down here is angle A and angle B are inscribed. How are their angle measures related? And what's true is they're equal. Now to find out what those angle measures are, we use theorem 9.13. Theorem 913 says the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. So to prove this, you actually would have to prove 3 cases. Case 1, where one of the sides of the angle goes through the center. Case 2 is where the center is in the interior of this angle. And the third case is when the center is in the exterior of that angle. Before we look at some examples, I need to show you just a few more theorems. When you have theorems that follow directly from another theorem, they're called corollaries. They're so very closely related that we are listing them as theorems, but they are actually corollaries, which means they're very closely related to our theorem. So theorem 914 says, if 2 inscribed angles intercept congruent arcs, then the angles are congruent. Now that's just the converse of what we just got done saying. So if you look at these 2 inscribed angles, I should probably note that this is only true if the 2 circles are congruent. So it's true for congruent circles. Or you could write 2 angles inscribed in the same circle. But it's important that the circles are the same size in order for this relationship to be true. If the angles are congruent, the arcs are congruent. And if the arcs are congruent, the angles are congruent. Okay, the next one says an angle inscribed in a semicircle is a right angle. Okay, take a look at this circle, and here's a diameter. So this entire inscribed angle has been inscribed in a semicircle. This semicircle is what this angle has been inscribed in. So what that means, if we look at our measurements that we've talked about already, this arc right here, that's a semicircle, that's 180 degrees. And we just learned that the measure of an angle that's inscribed is 1/2 of the measure of the intercepted arc. That means this angle right here must be 90 degrees because it has to be 1/2 of the arc that it intercepts. So any right or any triangle that's inscribed in a semicircle is going to be a right angle. And then the last one, it says the opposite angles of an inscribed quadrilateral are supplementary. Okay, I've drawn a circle here with a quadrilateral inscribed in it. Now, this is a rectangle, but it doesn't matter what the quadrilateral looks like. What is true is that if I have this angle, that's going to be 1/2 of this intercepted arc. And then if I look at this angle, the opposite angle, it's going to be 1/2 of this intersected arc. So if you look at the green arc here and the blue arc, that makes up the entire circle. And the entire circle is 360 degrees. That means the sum of these 2 angles has to add up to be 1/2 of that, which is 180, which is what makes them supplementary. Okay, here's a sample problem. We have circle M, and we're given that the measure of arc, RT, is 80, and the measure of this arc here, QS, or SQ, is 64. So we're going to be asked to find a few different things. The first one is the measure of angle QTS. So let's find that, QTS. So I'm just going to highlight that so that we can see where that is, QTS. Now, you just need to notice that it's inscribed because it has its vertex in the circle and that it cuts off this arc. So if this arc is 64, then this angle must be half of that, or 32. Okay, I've written 32 here. Now we're supposed to find the measure of angle TQR. So TQR. All right, so let me highlight that one. TQR. Well, let's see, the arc that it subtends is right here. So if this is 80 degrees, then angle Q here, RQT, must be half of that, so it must be 40. Now next we're going to find the measure of angle TQP. So I'm going to highlight that, TQP. Okay, that is not an inscribed angle. But what kind of angle is it? What if I look at this relationship right here? Do you see that I have a linear pair of this angle, which I know is 40, and this angle, which I'm trying to find? They're supplementary because of this linear pair here. So if this one's 40, this one must be 140 because the two angles together must add to 180. Okay, the last one, we are going to find the measure of angle P. So let's find that. Here's angle P. Now this is not an inscribed angle. It's not a linear pair with anything, but what is it? How can we relate it to some of these other numbers? Well, if you notice, angle P is part of a triangle. And in that triangle, we know that this angle is 32, this angle is 140, and we know that all three angles must add up to 180, which means that this angle is going to have to be 8 degrees, so that my three angles, 32 plus 140 plus 8, add up to 180 degrees. So you'll notice that when we did this, we used information about triangles, we used information about supplementary angles and linear pairs, as well as looking at our inscribed angles. So don't forget the skills that you already know. Okay, we're going to look at one last example. So given circle K with AB parallel to DE, so these two lines are parallel, and we have a tangent here, which means it just touches this point here on the circle, but it's tangent. And we're also told that AC and BC, the segments, AC and BC are congruent. I'm going to go ahead and mark those. So I'm going to mark those as congruent. And then it says that the measure of BAC is 56. BAC is 56. So I'm going to write 56 degrees right there. Okay, so the first thing I want to find is the measure of arc AC. So here's arc AC, and we want to find the measure of that, which means we need to know angle B. Well, do we know angle B? All right, I got to use some of my other math information, because if I look at the fact that this and this are the same length, that makes this an isosceles triangle. And we know that for isosceles triangle, if these two sides are congruent, their opposite angles are also congruent. So I know that this angle here is also 56 degrees, which then makes the arc that we're interested in twice 56, which would be 112. It's 112 degrees because it has to be twice this. This 56 has to be half of this. So this one must be 112. Next, we're going to find the measure of arc BC, which is right here. You can do that a couple ways. First of all, since these two segments are congruent, these two corresponding arcs are congruent. So right away, I know that this has also got to be 112 degrees. Now, I could have also found that because 56 is the inscribed angle, so this has to be twice that. Next, we're going to find the measure of angle ACB. ACB. So we want this angle here at C. Well, that goes back to the fact that I've got a triangle right here, and I know that the angles of a triangle must add up to 180. So if I add up 56 and 56 and subtract those from 180, this angle must be 68 so that they all add up to 180. Okay, so I took 180 minus 56 minus 56. That's where that 68 comes from, because these three angles have to add up to 180. Okay, and the last one, I want to find the measure of arc AB. And again, this is the arc, and there's a couple ways we can do that. First of all, the entire circle has to add up to 360. So 112 plus 112 plus whatever this is has to add up to 360. And if you do the subtraction, that makes this 136. Another way to do that would be to take this angle, and since this is the arc for that inscribed angle, this number must be twice what this number is. And one last way that we could have found the measure of arc AB would be to realize that the entire circle has to add to 360 degrees. So 112 plus 112 is 224. What I would need to complete that 360 is that 136 degrees. Okay, so just as a reminder, you are going to always have to remember the different geometry skills that you already know, because they will always kind of creep back into problems regardless of the skill that we're working with at the time.